In this video, we're going to be looking at the chain rule and how we can apply it to help us find the derivatives of composite functions. So I'm going to actually pull up what's in your book here for the chain rule. Here's what it says. It says, whoops, there we go. If f and g are functions and y equals f of g of x, so there we can see that composite function notation, then to find the derivative of y, we take the derivative of f of g of x and we multiply by the derivative of f. Now, when you look at this in this format, I think, me personally, I think it looks gloriously confusing. It's like, wait, what did you just say in English? So we're going to take a look at what this chain rule is actually saying, okay? So we had this thing that said if we have y is equal to f of g of x, and if we want to find y prime, that's f prime of g of x times g prime of x, okay? So when we think about our composite function, I'm going to make us one. Let's say we want to find f prime of x if f of x my stylus doesn't want to work. There we go. Equals, let's say 2x squared plus 1 quantity cubed. Okay. So we want to find the derivative of this. And because we've talked so much about derivatives of power functions, you know, things that have the, or not power functions, yeah, power functions, polynomials, there we go, that have bases raised to exponents, we can see here that we've got this 2 out front, we've got this 3 here, and it might be really tempting to say f prime of x is equal to 2 times 3 times x squared plus 1 squared, right? Because that's, if we're thinking about what we were doing before, we brought, to find the derivative, we brought the power down and it multiplied, and then we subtracted 1 from the power. And that's absolutely correct. The problem is, what about this piece, right? It has a derivative also. The x squared plus 1 also has a derivative with respect to x. And so the idea with the chain rule is that we still do that normal stuff that we would do to the outside function, but we also need to take into account, by multiplying, the derivative of the inside function, which in this case is going to be 2x, right? And then the plus 1, the derivative of that is just 0. So once we're all finished with this particular problem, it's going to say f prime of x is equal to 2 times 3 times this 2. That's going to be 12x, because we had this x right here, times x squared plus 1 squared. If you wanted to, you could FOIL this together and then you could distribute the 12x. That would be totally doable. But we can just leave it in this form as well. Okay, the 12x times the x squared plus 1 quantity squared. Let's take a look at another example. We want to find f prime of x if f of x is equal to, let's say it's the cube root of, I don't know, uh, x to the fourth minus 3x plus 1. Okay, so let's say that's what we've got. First thing I would recommend doing is if you're dealing with something like a square root, a cube root, etc., that you rewrite the function so that it looks like something in parentheses being raised to a power rather than having the root symbol. So cube root of x to the fourth minus 3x plus 1 is the same thing as x to the fourth minus 3x plus 1 to the 1/3 power. And that just makes it easier, I think, to find the derivative, because then it's really clear that this is just, we take the power, we bring it down front, we subtract 1 from it, right? It's our normal derivative stuff. So when we're thinking about using the chain rule here, we take the derivative of the outside function, so that 1/3 is going to come down front, and we're going to subtract 1 from the power, right? That's always what we do when we are finding the derivative of functions that look like this. So we're going to have a 1/3 x to the fourth minus 3x plus 1 raised to the 1/3 minus 1 is going to give us negative 2/3. And then the chain rule says, oh, wait, but don't forget about the derivative of the inside function. So we're going to have to chain out and multiply by 4x cubed minus 3, right? That's the derivative of the polynomial on the inside of the parentheses. And then again, you have options for how you tidy it up from here and make it look nice. I might do something like this. I'm going to actually distribute the 1/3 into here. So I'm going to have 4/3 x cubed minus 1/3 times 3 is going to be minus 1 times x to the fourth minus 3x plus 1 to the negative 2/3. Okay, and that would be one possible option for what the final answer looks like. You don't necessarily have to clean it up that exact way, but that is one way to do it.